Greetings and welcome, friends. Mr. Wada here. We're in section 11.4 talking about three-dimensional figures. A three-dimensional figure or solid. Do me a solid here, friends. Let's learn about these things here. Solids is bounded by a flat or curved surface that enclose a single region of space. All right, so we are no longer working on a two-dimensional plane. We're working in three-dimensional space. And here we go. A polyhedron is a solid that is bounded by polygons, right? Polygons. There we go. Called faces. All right, that makes sense. So here's a face right there. Yep. So there's faces. An edge of a polyhedron is a line segment formed by the intersection of two faces. So here's an edge right there. There's an edge, right? And a vertex is the point at which edges meet, or multiple faces meet, like there, right, Jack? Thank you, sir. Thank you. Right, three or more edges meet. The plural of polyhedron is polyhedra, or, wow, I have not known that, or polyhedrons. Oh, okay. Or hydra. Hail Hydra. Core concept, types of solids. No, I'm sorry. I don't even know what universe that is. What DC, Marvel, one of them. Whatever. And just kept going, like just commit. Okay. So types of solids, they come in a couple of families. You have polyhedra made up of polygons and non-polyhedrons where you might have a curved surface that is making up, right, a part of that, and a sphere is just like all curves, right? That's craziness. That's crazy. What's crazy? As far as naming polyhedron, there are some naming conventions that aren't too crazy. You name a prism or pyramid by its base. So a prism is box-ish. It has two parallel faces to one another, a top and a bottom, you could think about it. And a pyramid has a base, and then they converge at a single vertex at the top. To name a prism or pyramid, you name it based on its base. It's all about that base. What? No. Yeah, so here's a pentagonal prism. And yeah, you could have, here's a triangular pyramid. Square pyramid. Square pyramid. But yeah, you could have hexagonal pyramids. So prisms have two parallel bases. You can imagine these as being like the floor and the ceiling, right? So there you go. So some of what we're doing today is simply just classifying these solids by name, right? So we're just doing some vocabulary stuff. So classifying solids. So this would be, first of all, is this a polyhedron? Yes. And this is some sort of, looks like if I call that the base, this would be a rectangular prism. Let's see. Oh, here's, yes, this is all made up of, it looks like it's got a hexagon and then a bunch of triangles combined. And this is a hexagonal pyramid, as we were just talking about a moment ago. Right, so pyramids have a single base, and then they converge at a single point above it, like so. And is this one made up of polygons? No, this is no, not a polyhedron, and no. And what would this one be called, do you think, if you had a name for it? This is just called a cone. Yeah, there you go. Not that bad, not that bad. Here is question. They don't have to be regular. Actually, even in the case of this pyramid, these are isosceles triangles, not regular triangles. Good question. How about cross sections? If you imagine you went Fruit Ninja on a series of solids and sliced it, the cross section would be the shape that is the new exposed surface. So this is a square cross section. Here you could have a rectangular cross section. You could even have a cross section that is a triangle here if I slice just the corner of that like so. So no, I mean you could Fruit Ninja this any which direction or angle you guys wanted, right? You could just go Fruit Ninja crazy on this, slice and dice. So here, these would be very difficult to draw, by the way, especially like this angled plane one. So let's describe some cross sections together, shall we? Right, like I said, not too tricky, just a little bit of vocabulary. So if I first of all, okay, for A, let's call on someone. Alyssa, what type of shape do you think this is? A prism or a pyramid? A prism. And Malik, what is the base of this prism? Yeah, now that's a tricky question, right? You might have wanted to call the base the thing that's touching the floor, apparently, but that is not necessarily the base. Someone tipped over this hexagonal prism, and then they sliced it right down the middle. And what do you think the cross section's going to be, Jack? So they sliced this. It looks like this is the cross section. So that's, yeah, the hexagon is the cross section. All right, okay, let's see. Isaiah, what type of polyhedron is this? Triangular pyramid. Yeah, it's got a triangular base. And Lily, what do you think the cross section might be? Looks like they cut it with a horizontal plane. Yeah. And if the base of this was a regular triangle, you could cut this at an angled plane and have a non-regular triangle as the outcome. Ooh, I like C. Haley, we didn't name this yet, but what would you call this solid? It's not a polyhedron. A cylinder, yeah. And Ty, if I vertically slice a cylinder with like a 1,000-degree knife, for some reason, trending, what would this cross-section be? Yeah, that looks like a rectangle right there. Cuts open geometric solids. That would be pretty great, just to see if I can get some views. No. So let's see. This is a cone. This is actually a circular cone, by the way. I imagine that if I looked at this top down, that it would be a circle. It is also possible, by the way, to have like an elliptical cone, but I'm not even going to try to draw that because it'll look pretty much the same. Horizontal slice. Well, it could. If I horizontally slice this, this would be a circle. If this is a circular cone. What if it is slightly angled? Then it would be elliptical, yeah. An oval is yeah. That'd be another way to describe an ellipse, perhaps. Here is a sphere, and if I cut this in half, I get a circle as the cross section. And does anyone know what half of this sphere would be called? A hemisphere, yeah. Is there such a... Do they call this like an octosphere if I like cut it into eighths? A semisphere? I like this one. Look at this awesome cross-section. And this, I believe, is an isosceles trapezoid. Now, guys, embarrassing. Geometry teacher just forgot how to spell trapezoid. I think it's with an E. Whatever. Yeah, I'm fine with it. Oh, guys, look at this awesome job. What? This is so cool. I'm glad I set you guys up for success on these with partially drawn images. So sketching, a solid of revolution is a three-dimensional figure that is formed by rotating a two-dimensional shape around an axis. If you guys go as far as calculus or further, you will actually be able to find the area within a curve or a line region and be able to do calculus rotations of that and find the volumes of solids that are rotated is what you'd be able to do. So yeah, yeah. And it's actually something that in calculus you could figure that out. You could actually also even have say on the x-axis, actually you guys haven't seen a curve like this yet, but here's like a third-degree polynomial. You could actually also find the area of this under a section of this and then rotate that around 360 degrees on the x-axis and actually find the volume of that rotated figure, which is weird. But you can do that in calculus. It's a pretty great, powerful tool. And that's called the axis of revolution, and blah. So let's look at example 3 together. So like I said, I think this is actually just more artistically challenging, or like in terms of three-dimensional perception. So here we go. If I rotate this figure around this axis, I like to try to, let's see, I'm going to just draw something like this. Yeah, and it's going to be a cylinder that's sideways. I like it. Right? A cylinder with a radius of 4 and a height of 9 is what that would end up being. Right? So so there you go. The way I did that was I kind of just drew like these arcs that were parallel to each other, so to speak. For this, you could start by just mirroring this point over here or like this point over here, right? It's gonna mirror it, but more than just mirror it, it's going to rotate it. So I would draw like an arc in front and an arc, dotted line arc in the back. And you could kind of imagine that as a cone. And then become like a sphere? Yeah, yeah. That would be a great physical example of this. So this is a cylinder, and this is a cone, right? I was actually just thinking of this particular concept. What if I had a part of a rectangle on a diagonal rotational axis? So it would have like this part of it would be like a conical base. All right. This part would be rotated. Oh boy. And then it would have like this hollow point, if I could use that terminology in a non-violent way, I don't know. Right? It would actually have like a dimple of a cone inside of it. I don't know. It'd be weird. But yeah, it looks something like that. Let's actually, if just as the last thing I'll show you here, let's say I want to draw a hexagonal prism. Okay? What I would do is I'd imagine a hexagon and then smoosh it in one direction, okay? All right, kind of like a sideways rupee from Zelda. R-U-P-E-E. No. And then I would pick a point, and a right pyramid, by the way, is a figure that has its vertex directly above and perpendicular to the base's center. And then I would draw the edges from the vertex to these. Okay, so if you're trying to draw some of these tonight, most of the drawings are already made for you. But right, I just kind of connect those dots. Right, and then if you want to start trying to implement, right, dashed lines for dimensions that are internal or right behind the solid, you could do that as well. And technically, I should have dashed these lines here and here. Right, but so yeah, you guys can try drawing some of those. So thanks for watching, internet friends. This was Art with Mr. Waddy.